So we are done with our geometry. Now we will see our meshing. So let's start meshing. Now we will use structured mesh. In order to do that, we will map our geometry first. So select the mesh, right click, go to show and mappable face. So this is the mappable face that we can map. So keep this and go to mesh control, mapped face meshing, and then generate your mesh. Now this mesh is very coarse, so we will change this mesh from coarse to fine. Update. Now the number of mesh we have is only 1300, which is not very good. So we will change the sizing and we will reduce the mesh size. We will change it to 7.5 millimeter and update. Now you can see we have a fine mesh 4000, which is still very coarse. If you want, you can change this mesh or you can keep it as it is, but we will stick with this mesh. And actually we can reduce the mesh size a little bit. So go here, change it to 0.75 to 0.5 for face, and then update. Okay, so here we have 9000 mesh. Now select the edge selection tool, select this line, create name section. This is our air inlet, and select this line and create name section. This is outlet. Now update one more time. So here your meshing is done. So now we will see the case setup for multi-phase flow. So let's start Fluent. Select Fluent, 2D, start the Fluent. Now first you check your report quality. Now we have a minimum orthogonal quality of 0.99, which is pretty good, but in terms of length scale the mesh is not that good, but it's okay for our case right now. So we will do a pressure based 2D simulation, and definitely multi-phase flow will be transient. Select the gravity, and we have to give the gravity. As you can see here in the meshing, we have the coordinate system XY plane, so our gravity is acting downwards. So give the gravity value minus 9.81 meter per second square, and our velocity formulation is absolute. Now go to model. So we have multi-phase flow, so go to multi-phase flow, edit, and we have three options: volume of fluid, mixture, and Eulerian multi-phase flow modeling. We will use volume of fluid, the famous VOF modeling, and we will use explicit scheme with implicit body force. So select implicit body force, and the number of Eulerian phase right now is 2. So we will use water and air, and that is the 2 phase for our simulation. So select OK. Now go to energy and turn on the energy equation. Yes. Go to viscous model. Go to K epsilon, select the K epsilon model. We will use standard K epsilon model and standard wall function. Select OK. So our model section is set. We will use volume of fluid method for multi-phase flow. We will use energy equation for hot air temperature prediction, and we will use standard K epsilon model for viscous modeling. Now go to material. Right now we have air, so we have to define water. So go to create and edit, select the fluid and go to Fluent database, select the liquid water, copy it, select OK and close. Now we have liquid water and air. Now in the phase option, if you see closely the previous tutorials, this phase option was not active, but right now this phase option is active due to this model. We have selected a multi-phase flow model. That's why this phase option is right now active. So we have two phases. First one is the primary phase and second one is the secondary phase. The primary phase is actually the domain where you have your primary fluid. In our case, we have a water tank. So for our case, the primary phase will be liquid water. So select liquid water, and the secondary phase will be air. So okay. The cell zone condition here, you can see the type is fluid and phase is mixture. So the cell zone condition will be the mixture. We don't need to change anything right now. We will change it in our boundary condition. Now go to boundary condition. This is very important. The air inlet, first of all, in the air inlet section, select the phase mixture and velocity inlet type. Go to edit and put your velocity 0.01 meter per second. And the intensity and hydraulic diameter, we will change it 10% intensity, and hydraulic diameter is quarter inch, which is 0.00635 meter. So the temperature is 323 Kelvin for 50 degrees Celsius. Select OK. Now select the air inlet and change the type, phase type. Select phase 2, velocity inlet and edit. Now you can see we already selected the air inlet as a mixture and gave the velocity, but right now for phase 2 the momentum section is inactive because we don't have any option to give the velocity. We will change the phase. So the volume fraction at the air inlet would be 1 for phase 2, and for phase 1 the volume fraction would be 0. So select OK. This is very crucial boundary condition. Now go to outlet, select the phase 2 pressure outlet and go to edit. Still we don't have any momentum option, any thermal option, only we have multi-phase, and here the backflow volume fraction would be 0, so that the air bubble will stay inside this tank. Select OK. Now you don't have any boundary condition left for this section, so go to solution method directly, and here for multi-phase flow we use simple scheme with least square cell based discretization for gradient, but for pressure we use Presto, and for volume fraction we use GeoConstruct. You can change the turbulent kinetic energy from first order to second order. Also you can change the turbulent dissipation rate from first order to second order. Now go to solution control, leave it as it is, just change the momentum value. Go to monitor, and these things are fixed, so we don't need to worry about these things. Now go to solution initialization, hybrid initialization, select initialize, and it will initialize. And then go to add up, go to region. We will mark the region. The tank is the phase 1 and the inlet is phase 2, so we have to mark this for multi-phase flow. So put the values for our tank. So our tank width is from 0 to 10 inch and height is from 0 to 36 inch, and we will select add up, yes, and then we will mark it. Now close this, go to patch, and for phase select mixture phase 2 volume fraction, put value 0 because this tank is phase 1, so the volume fraction of phase 2 would be 0. So 0, select surface body and hexahedron, patch region, patch, close it, go to run calculation, select the time step 0.01, number of time step 300, and maximum iteration per time step 1. Start calculation. Okay, so now it will start calculating the solution. So our solution has been done, and in the next tutorial we will see the results and some post processing. Thank you.